I think the future is going to be very exciting as we can bring the technology to speed of innovation with Moore's law and other capabilities faster into these to make the system safer. And I think the opportunities are endless.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 70. What does it mean now that Intel has entered the drone industry? If you ask that question of today's guest, I think he'd say the possibilities are endless. Anil Nanduri is Vice President of the New Technology Group and General Manager of the UAV segment at Intel Corporation. He's responsible for establishing Intel's unmanned aviation systems business and pursuing opportunities for growth in this segment. This group has been developing innovative new applications for drone technology. He's here to talk about Intel's entry into the drone industry, some of the products and technology that Intel is working on, and he'll provide some insights into where the drone industry is headed. Let's pick up the interview where I asked Anil to introduce himself.
I'm Anil Nanduri. I run the UAV group at Intel, and I'm a vice president in the New Technology Group.
Intel has been around for a long time and is primarily known for its computer chips and processors. When did Intel enter the drone industry?
A couple of years ago, we started work primarily using real-sense technology for collision avoidance.
Was this seen as a natural step for Intel or something new?
So when we looked at real-sense technology, we were starting with PCs and tablets. And then what we were trying to go see is how this can be adapted to new applications like robotics. And in drones, which is up and coming, we know that collision avoidance was a key capability that would benefit the industry in that space, because as these unmanned vehicles are flying, one of the key aspects is how do I give them visual intelligence to detect obstacles and navigate and detect people.
Is there a simple way to describe how RealSense works?
It's a depth sensing camera, and there are multiple versions of how you can do depth sensing. But what makes it interesting for outdoor use is a stereoscopic method, where it's just like the human eye, where you have two cameras. And a lot of the, you take images in parallel, and you're able to then translate that to being able to capture depth information. Now, how do you do that is you're looking at multiple images, looking at the distance between the two, just like the human eye does. If you close one eye and open the other eye, you can see the two images. Being able to do that in a format where you are primarily doing all the computation on board. So in the past, something like this, the algorithms are very, the concept is actually very simple, but the algorithms to run it took a lot of compute. So what we've done is we actually have an onboard chip on the camera itself that does all this calculations.
In addition to the sense and avoid, does the system have the ability to remember what it sees?
Depends on how you want it. So the camera itself doesn't store any data. It passes through all the information like a live feed. Now the algorithms that are using it can then decide and decipher. You can actually scan a person. So by the way, this capability can be used for gesture recognition, emotion recognition, or to be able to scan in 3D, augmented reality. There's different kinds of applications. But in the drone-specific application itself, we use it to understand obstacles. And now basically for a drone, what is important is there space to fly. And so you can think of it as a map in 3D. It maintains for a certain amount of time. Now, keep in mind that as you store more maps, it takes more complex algorithms to manage that data. So sometimes it's actually simpler just to know real time, is there an obstacle or not, or go around it. It's not necessary that you need to maintain that history of state.
Is there a way to measure how accurate it is? Do you know if the sense and avoid has gotten better and will get better in the future?
Oh, yeah, definitely. Beginning cusp of where the technology is going. So you're starting to see the first versions and instantiations of it. But as the sensors get better performance, better capabilities, they start to become more robust and work better outdoors, you'll start to see more implementations of this. Now, there's two aspects from a drone use case. One is what's the sensor itself, but it's also important where I'm flying, how fast am I flying. So you start to see multiple sensor fusion information get in, right? So it not just depends on real time, just using on one set of sensors, it's going to start being more smarter about, okay, I'm flying at low altitude, or I'm flying in a dense area where there's people around. You start to get that smartness built in over time as well.
Currently, which products or applications is Intel's RealSense being used?
Today, we have actually demonstrated in the Typhoon H, unique Typhoon H with RealSense. That product's actually in the market. It's on a drone. It uses collision avoidance for follow me feature. Also, it was available in PCs. HP launched a tablet with it. But again, the PC and the tablet ecosystem, they're in a different cadence. But in the new markets, we demonstrated this in a mixed reality headset. Project Alloy uses RealSense. We use it in robots. Asus Zenbo robot is using RealSense. The 9-bot robot with RealSense technology was used. We showed that at CES. We had many other applications and technology. The DAC-3 helmet, the smart helmet, was using RealSense technology. So there's multiple kinds of applications, from mixed reality, augmented virtual reality, as well as robotics and drones, where you see a lot of interest in this capability.
When you get into augmented reality, is RealSense being used to make sure drones are not running into things in the real world? Or is it being used to allow the user to interact with data that may reside on the user screen?
No, so the augmented reality, the RealSense is on the headset for the user. So it's either to understand the depth in the real world for the user itself. So augmented reality is primarily wearing smart glasses, where you're using it for augmentation, or you're using it on a smartphone for augmented reality. So in those kinds of uses, you want depth sensing to be able to accurately put virtual objects in the real world, right? From a drone perspective, it's primarily for collision avoidance of the drone itself. It's a more of a safety feature for the system is how we see it.
Now, Intel also has a new platform called, I believe, the Intel Aero.
Yes.
Could you tell us about it?
Yeah, so when you look at the ecosystem for drone developers, we are trying to help find applications where the developers can actually bring new capabilities to the ecosystem, build applications and software enhancements in the ecosystem. A lot of the work that's going on, people are building their own drones, and we thought it would be a great idea to bring a standardized set of features and capabilities with open source software and computer interfaces that can make it easy to program applications for ready-to-fly kind of use cases. And so what we've done there is built around a ready-to-fly use case for a drone, where the developers are not worried about making the drone fly, but more about building applications on it.
So a developer can use the platform to create any of their own applications for a drone.
Mm-hmm.
Okay, what about the Falcon 8?
Falcon 8 is more of a commercial use case, so it's built for inspections. Very, very capable payloads, highly redundant system, and we want to bring the capability like RealSense to the commercial ecosystem as well. So we want to be able to bring that safety elements of RealSense for obstacle avoidance into the commercial use case.
Was the Falcon designed specifically for inspections?
Yes.
Is it available now for drone operators to use?
It's available in Europe, and we are working towards bringing it to the U.S., but yeah, it's more widely available in the Europe market. Switching
gears a little, Intel is not just developing drones and applications for drones, but it's also involved in some cutting-edge research. The one project that I was particularly interested in is Intel's 100 Drones project, controlling multiple drones at one time. Can you talk about this project?
The light shows was about bringing multiple drones per pilot as a concept of, how they can control these number of drones safely. And light show was a great way to bring that experience because, anything with lights has a human imagination, and fireworks is something that has always inspired us. And so how can we bring the technology to drive a capability like this and not just do 100, but do hundreds of them? And so we're looking at, and it's not just about the art in the sky, and which is more of an art form, but it's technology that's driving it, and the controls that help manage this safely is an important element of it, and building capabilities and innovation to push these forward to go from 100 to hundreds to thousands.
If I understand the potential application of the technology, today a drone operator with one drone may need to make several passes to survey a large farm. But with the Drone 100 technology, that same operator could control several drones at once, covering more area in less time.
Yes, and so you can, and by the way, in future you can conceive of, search and rescue capabilities that can actually help enhance this with having multiple drones or fleet of drones with one control to be able to help and assist in search and rescue, for example.
What goes into controlling multiple drones? Is it the software, the hardware integration? What are the key factors that make it possible?
It's a combination of, first of all, the ability. Obviously, there are variabilities in flights and they drift, and how do you maintain the flight system in that regard? Number two is being able to communicate and manage, and how do you make sure that you have enough capabilities that help do this safely? And the third one is how do you able to get all of these updated and working together in a cohesive fashion simultaneously? So how do you maintain all the rules that are required for them to not collide into each other, for example?
Are the drones sharing data to stay on track, or is the data sent to a central hub for processing?
Yeah, it's managed by the master computer.
Now, I saw a video of the drones in action at Vivid Sydney. Was this the only time that they've flown?
No, actually, we've flown a few times. In fact, the first time we did 100 flights was actually a couple of times in Germany last year. And then we did a private event in Palm Springs in California this year. And then Sydney was the first public event, 5 days, consecutive nights. And we also did an event like 2 weekends ago in Linz in Austria.
Are you getting some calls from people around the world that want to see the technology in action?
Oh, yes. There's plenty of interest in this. And in fact, like I said, the future where we want to take this from 100 to a lot more than 100 is something that I'd love to go see.
I've read that they could replace fireworks one day. Do you think that could happen?
I think there's more than this. This is about, think of it as a display in the sky. There's animation that can be done more real time. Now, fireworks, of course, is a future where I'd like to see this being, it's a lot more greener and it's reusable. Clearly, it can augment fireworks and in some cases even replace fireworks in the future. But the thing that fireworks has is the audio effects of the fireworks. How do we comprehend that? So the way we've handled that is combining the art form with music and live orchestras so the audience can experience the full show. So there's clearly ways in which this can be instantiated. But yes, the vision we like to see it someday is a different form of entertainment, if not replacing fireworks.
Any other Intel technology for the drone industry that we should mention?
We are also using the flight control technology. We've done an event that we're working with a company called Evolo, did manned aviation. So they did a drone copter. It's a person carrying electric copter, but using drone technology. So it's very easy to fly. But the flight control technology that's used on UAVs is exactly what's applied there. It's a multi-rotor system. It had 18 rotors. So we built electronics and capabilities that drive that kind of a vehicle as well. So the flight control, the rotor electronics, as well as some of the battery management electronics was designed by Intel, Ascending Technologies, which is part of Intel now. So the team has designed that. So it was a good use case, and it's certified for test flights in Germany. So they've got approval to do that in Germany with the registration and has an N number for test flights.
With your perspective of being able to see technology worldwide, what do you see as the major trends in the drone industry that we should be made aware of?
First of all, FAA, by embracing the Part 107 rule or releasing it, is actually now at least putting up a process in place to bring it to the airspace. So I think it's very exciting to see a lot of commercial applications where really useful applications where drones can be applied can actually materialize in reality. The second part of it is that I believe that integration to airspace is you want airspace to be safe. So there's a burden both on the industry as well as the regulation to work together in bringing that in a safe way. I think the future is going to be very exciting as we can bring the technology speed of innovation with Moore's Law and other capabilities faster into these to make this safer, make the system safer. And I think the opportunities are endless. We can get this to be integrated into airspace in large numbers, and which I believe and I'm passionate about is the future. Now, people's perception and mechanics of privacy are all very important aspects of it, but I think we need to work in the framework that already exists and bring this in a way that we people feel comfortable having these fly over the sky. So the first step is visual line of sight, flying under 400 feet. Next would be an aspect of, okay, how does this fly safely over people? And then how do you go beyond line of sight? And how do we be able to have full autonomy in unmanned aviation vehicles?
Is Intel involved in any policy formulation nationwide? Do you work with major government organizations to make sure sensible drone policies are crafted?
Yeah, so we actually work very closely with the FAA. In fact, our CEO is also the chairman of the Drone Advisory Committee as an industry and a government collaboration to tackle some of these big challenges that I just laid out, and being able to bring capabilities in a structured, risk-based approach to the airspace. So we work very closely to bring that thought leadership into the ecosystem, represent the industry, and help this new up-and-coming segment with the experience and the history of Intel bringing new technology to the market.
I'm curious, what excites you most about this technology?
One is that there's actually very, very credible use cases that you can connect to any person out there, how UAVs can help us, be it in search and rescue, first response, and in terms of natural disasters or monitoring erosion, deliveries, and improving our lives to get goods faster, or a lot of it in terms of inspections and commercial applications which start to excite. Even consumer applications like taking a video or a photo from a drone, if you've seen it, it's amazing as to what this technology can do, which you would have to have Hollywood-level capabilities 5 years ago to have that experience. And so how much it touches such a wide range of industries, segments, people, and applications, that's what keeps me going, saying that is so real because you can actually see the value of it, you can explain it, and you can realize it. And I think that's what makes this very, very exciting.
I think most people would agree that Intel's computer chips and processors transformed an entire industry. Do you think UAV technology has a similar transformative nature?
This is one of the many. I think there's many applications where there's expectations, but I believe UAVs definitely have one of the strongest value propositions, and being able to apply our technology and make them safer or bringing new intelligence to these devices, I think clearly it will drive vast amount of storage, needs for the server computes, intelligence on board itself for real-time processing. I see many places where technology plays a role, communications, and for us, be able to play a role in it, shape it, and be part of that ecosystem itself would be a wonderful opportunity and also a value we can bring to this ecosystem.
That's it for episode 70 of the Drone Radio Show. I hope you enjoyed hearing from Anil Nanduri and learning about the exciting things in the works at Intel. If you're interested in learning more about Intel's UAV technology and their applications, check out their webpage at intel.com. Or you can check out the Drone Radio Show page for a direct link. If you enjoyed this episode, please leave a positive review on iTunes. It really does help. And as always, I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Gores.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.